Okay, welcome to episode 2 of my thickness training. So in this episode, we're going to go over blank size and understanding the prescription. So let's jump into it. So we kick off with blank size. Okay, so why is it important first off? So firstly, it's important to know it's only applicable to plus lenses. Minus lenses, it makes no difference. For just refer back to episode 1 where we spoke about the lens form. Obviously the curvature of the lens, with a minus lens doesn't make any difference at all whether you have a teeny frame or a large frame, or indeed a blank, because it doesn't make any impact to the end result with the glasses. It helps for those unable to pay for high index. So if you're quite selective with, so the smaller the blank, the thinner the lenses are essentially. So that's where the frame selection, where we come to in episode 3, is going to come a little bit more into it. Giving the correct blank size will help the lab ensure they can order the best lens possible for the best price. So obviously that helps with the profit. It also makes things a little bit quicker as well, a little bit better for the patient. So here's an example of what happens when it does go wrong. Now, it's a bit unfair to say this has gone wrong, but there are certain things we could do better. So as you can see, this here is where the thick edge is, and believe it or not, this is where the thin edge should be. Now what has happened there is that's a classic example if the blank size is too big. Now, in terms of the actual dispense itself, you can't see it very clearly through the bag, but that there is where the frame is. Actually quite a good dispense. The eyes are nice and central. It was a fairly good size. Is just, I can't off the top of my head remember exactly what had happened, but somehow the blank size that ended up being ordered was far too big, because the way it should work is this should be a thick edge and it should go down like that. So it should be much smaller. Well, that's not very straight there, but you kind of get the idea. So if it's ordered correctly, I didn't take the lens out because this is a finished job. So as you see, it's an actual order from a patient. The prescription between the two of those is identical. But see how much more thinner that is. So that, therefore, the blank size has been ordered correctly. The index is exactly the same. There is a small difference here. The first example one's too big, I think, was a stock lens, and this one here ended up being surfaced. We only did that because it was a customer complaint. Now, if the blank size had been ordered correctly in the first place, we probably wouldn't have needed to, because it probably would have been nearer to the where I've drawn there anyway. So, but that's what happens if it does go a bit awry. Anyway, so how to calculate it, just as a bit of a refresher. Before we go into this, a handy thing to, when you're doing a regular dispense, if it's one of our own frames, our system is set up in such a way that when they come to be ordered in the lab, the blank size is automatically ordered correctly. But if you've got a P&A or it's a bit of an unknown quantity, we do need to know. And like I say, especially if it's a plus lens. If you having a minus lens, so say for example you've got about a -3, it doesn't make any difference. You can just, without even looking at calculating it, you can just type in a 70 blank and it's done. That symbol there incidentally is the symbol for a blank size. Any lab, including ours, will know exactly what that means. Okay, so this is the equation we use. So it's FPD, or the frame PD, minus the PD, so that's the customer base, so that's obviously the both eyes together, plus the ED, which is the effective diameter, plus 4 for wastage. That equals your blank size. So let's work through an example. So this is where the various things are. So the frame PD is typically the bridge, or the DBL, distance between lenses, plus the box A measurement, which is the widest measurement here. So I've actually done that a little bit wrong in a way, because this top arrow there for the frame PD should be a bit further down. And the ED, or effective diameter, is the longest measurement on the excuse me, as longest measurement on one particular eye size. It's going to be either the same or larger than the this measurement here, the A box measurement. You can see these actually written in, because the FPD here is typically the A measurement plus, you'll see, so this one, I think memory serves, the frame itself was 55, and you'll see a little box in between, and the bridge was 18. So 55 plus 18 is, let me see, memory was off the top of my head, so I normally use the calculator. Right, so that's 55, so that's 65, 68. So that's a frame PD there of 68 is going to be FPD. So this ED here is going to be at least 55 millimeters. Typically it's around normally the same. It's very rarely different of 1 or 2 millimeters, but that's what they are on that example there. So we're working through an actual example here. So your frame PD here is 68, which I think is what we had there, wasn't it? Yeah, 68. So yeah, because I use this one as an example. The PD, the patient PD is 63, and the effective diameter is 54. So putting that into your equation, a 68 minus 63, which is obviously 5, plus 54, plus the 4 for wastage, equals 63. So you round up to the nearest 5 because they don't come in at 63 blanks from the supplier. They come in either, zoom in a bit quickly there, so they come in either 50, 55, 60, 65, 70, and in some occasions 75. Now, really handy rule of thumb here for you. If you're doing this blank size and it equates that, remember the magic rule of 3, the number when you need to start thinking about thickness, is if you're south of this line, so if you're 70 or 75 and you haven't gone for a higher length lens, the frame you've chosen is more than likely too big. You're aiming for, if you can, 65 blank you would get away with, but especially if you've got a high prescription, you need to get round here, if you can, 55 or a 60. Now, what is quite useful is if you've got a kid's job, which are typically plus lenses for whatever reason, they can normally get away with either a 55 and in some cases for really teeny tots, a 50. Now, because obviously kids update their glasses more frequently and they're normally on a 6 months to 12-month recall, obviously £75 is quite a lot of money for a parent to pay typically. Some people can afford it, then great, give them a 167 lens, it's the best thing for it. But they can't always. So if the blank you're calculating is going to be a 55 or a 60 and it's a plastic frame, they'll probably get away with it. So that's it there. In terms of what this for the wastage is here, when you obviously the optical centre of the lens isn't always in the perfect centre of the uncut lens. It sometimes is just the manufacturing techniques they're made from. Sometimes they're just ever so slightly off. So you need to allow that 4 millimeters for the wastage, and you need it to cut out so it does a good enough finish on the machine, whether that be a Supra, which you need enough room for the groove to go through, or indeed it being a full rim frame, which preferably you should be doing for this type of prescription anyway. So it's got enough for the B bevel to go in, so it gives the security necessary for the frame. So that's that there. So surface versus a stock lens. So going back to that example we saw where one was ridiculously thick and one wasn't. From a business point of view, a stock lens is always a preferred option because they are a surface lens is at least 4 times more expensive. I spoke to Shahid about it. I can't remember exactly how much it is, but when I said that they were about 4 times more expensive, he nodded. So I would ascertain to say they're probably at least 4 times expensive. So that's a key figure. So not twice as expensive, 4 times more expensive. So if you can imagine, from our point of view, being more profitability, it's better for us as a business if we use a stock lens. And if we're quite clever with the frame that we've chosen, which we're going to come to in episode 3, it's going to be much better. So a surface lens will come out better, as I've stated there, because obviously more work goes into it. It's more bespoke for that frame. Basically, the way they do it is they feed the information into a computer, and literally it spits the lens out as thin as it can be for that frame. But obviously, because more work goes into it, it's not the one that's just picked out of a packet. That's why the price is there. If you want to get it really thin, to get that sort of edge thickness that we've had on that previous one, you need to specify this. To get minimum thickness, you need to specify knife edge with a low base. That means then that thin edge, as you can see, is going to be literally knife edge. And a low base, that means obviously that's the base. So a low base means it's going to be flatter. So again, that's quite crude there. And the knife edge is obviously that thin edge there. So it's really, really thin. So obviously the thinner the thin edge is, obviously the thinner, the thicker edge is therefore going to be. But because those lenses are the 4 times more expensive, don't just dispense them willy-nilly, because you can say, well, I'll just do everything. But obviously, if you've been paying attention to what I've just been telling you, you'll know why that's not the best idea. If you think, though, that that's the best option for the patient, don't go promising it to them. Just go to a member of top team, or preferably Nabil if he's available, and say, I think this will be the better option for the patient. Their previous pair of glasses have come out really, really thin. Can we do this? 9 times out of 10, obviously, they'll say yes. So, excuse me, so I've got a bit of a tickle still. So yeah, that's there. But when we come to looking at a patient's previous pair of glasses in chapter 3, you'll see whether they're going to expect that or not. But I'd probably say about 8 out of 10 plus lenses are about +4 or above you'll do. They'll typically be surface anyway, especially if it's a high sill, or they'll be okay there. But if you choose a well-fitting frame and have a good frame selection, stock lens should always be okay. So going on to that here, we've got, I've brought up a snapshot actually of the lens thickness. So both these lenses here, as you can see, are aspheric. So one's aspheric, so one's regular, so it's a stock lens, and the other one is pre-calibrated. So on the +3, so you see it gives you about 10 mils of difference. So on the +3, so it doesn't give, on that type of prescription, much more. It's only, in my experience, it only tends to make a difference 6 and above. It's where it really comes into its own. It actually becomes being worth our money to go that extra mile. But as you can see here on the +3, if you pick your right frame, it doesn't actually make a whole lot more difference, 10%. That's less than a mil. In fact, it's about half a mil. Look. Okay, so understanding the prescription. Now, what I mean by this is when you receive a handover, one of the first things you should do is you should look at the prescription. So how thick are these lenses going to be? Do I need to consider thinning options? So what we do is we transpose the prescription because we need to find the highest, what we call meridian. And what we mean by that is the lens, that part of the lens that's going to be the thickest. So the bit that's going to cause, I want to say will cause the trouble, but no, the bit you need to be wary of to get the best possible substance for your patient. So it's doing this again. Jolly good. Right, bear with me. Let's got the markings again. Back to this. Right, here we go. So using a couple of examples here. So the first one we're going to use is a plus lens. So you've got +3 -250. So what you do here is when you want to transpose it to start with. So which is going to, but what does the transposition mean? So that transpose, those of you might remember, is +3 -250. So that's going to be a plus 050 plus 250 at 180. So when we come to work it out, so what that means is, so on the 90 degrees is +3, and on the 180 is your, where have we gone? +250. No, done it wrong, haven't I? Yeah, +250. Yeah, because your difference between them is that. Yeah, so, down myself now, +250, no. God, I forgot how to transpose. It's embarrassing on a live video, isn't it? So, as you can see there, you're looking for the one that's the thickest. So it's the +3, which is here. So your thickest edge there you want to consider is +3. Now, we typically write things in minus sill form. So obviously you rarely get one into this, but the point is you're looking for the bit that's going to come out the thickest. It's +3. So the consideration you need to make is a +3. Now, obviously, if you have a reading ad here of a +2, say, you've already ascertained that the +3 is your thickest meridian. Your thickest meridian is now going to be on a ad of a +2, +5. So that may creep you up to your 167s. Okay, so in a basic spheric lens with a 1.6, or the 167 would be better, but you could probably get away with the 1.6. You're going to really start needing to think possibly with a +5 especially if they go for a larger frame. But obviously, reading glasses, that's why a smaller frame is sometimes a little bit better. Okay, gets a bit more complicated actually with minus. Unlike when the skill of finding the best substance with the spherical lenses, minus lenses work a little bit differently. So going on the same sort of principle here, so along 90 degrees is what I should have done to start with. You got -2 on your 90, then taken away another 2, so you then got -4 across your 180. And that is where actually all the thickness is going to be. So where are we? So yeah, -4 +2 at 180. So across, so the thick edge here is going to be, sorry, it's my old SMC things coming in here. So you're actually going to be a lot thicker along there. So it's the point is when you've got a minus prescription, it's always going to be a bit more, especially if you've got a sill that's 1 or more. It does sometimes add to that thickness. So that's pretty much it there. So it's just when you get a prescription, you go to look at it and know how that kind of incorporates and think of the ad. So perversely here, if you had your reading out of a +2, you're back to a -2. So, but for some reason in my experience, myopes tend to have varifocals more often than people that are long-sighted for some reason. I'm not entirely sure why, but still. But anyway, so that's episode 2. Because we can go into episode 3 in just a moment. That just touches over those aspects. So, again, any questions, don't hesitate to ask me, and I'll see you soon for episode 2. Sorry, 3 even.